Good morning, I'm Doug Rombough. I'm the Vice President for Business Development for Logos Technologies. For the next 10 minutes, I'm going to talk specifically about what Logos Technologies does in the ISR effort, specifically miniaturizing our sensors. By miniaturizing these sensors, we can do two things. One, we can put wide area motion imagery sensors on smaller and smaller air vehicles. And two, we can add those sensors to a multi-sensor pod effort. Makes it much easier to keep the pod lightweight. But before I do that, let me just give you a short background on Logos Technologies. We're a science, engineering, and technology company founded in 1996. We're a small business headquartered in Fairfax, Virginia, and we primarily deal with advanced sensors, but also analytics, and of course, wide area motion imagery. So what is wide area motion imagery? Well, wide area motion imagery is also sometimes referred to as WAS, or wide area airborne surveillance, and sometimes also as WAPS, or wide area persistent surveillance, but they're all the same thing. It's looking at a medium-sized city area and recording everything that's going on in that medium-sized city area for real-time use, but also for forensic playback. This is an example of a wide area motion imagery, and you'll see that we can chip out streams of that wide area motion imagery and move that down to individuals on the ground. We can send that through a data link, and we can service up to 10 different users on the ground that might have a handheld tablet or a handheld phone. A little bit about the miniaturization of the history of wide area motion imagery and Logos Technologies. In fact, it was the president of the company, Dr. John Marion, who first come up with the concept of wide area motion imagery when he was at Lawrence Livermore Labs in the early 2000s. Out of that came Army's Constant Hawk. Logos built the first Constant Hawk sensor, but that sensor weighed 1,500 pounds and was in, the entire aircraft was taken up to fly that sensor. This is a picture of the sensor that Logos built for Army's Constant Hawk. Not long after that, though, we did another sensor system called Kestrel. Kestrel is flown on aerostats. It's both EO and IR, and it is 1/10 the weight of the Constant Hawk system. So big reduction in size, weight, and power for that system. That system was flown in Afghanistan and very successful, and it's still over there. Along the way, we were asked to miniaturize a daytime Constant Hawk capability to put on a UAS. We call this system LEAPS, which stands for Lightweight Expeditionary Airborne Persistent Surveillance, and it weighs 54 pounds. So that's 27 times lighter than Army's Constant Hawk. This is the system, obviously on a counter, but it was flown on the Shadow. Well, then along the way, we were asked to continue to reduce and innovate using commercial off-the-shelf technology, and we came up with our latest two sensors, which is Red Kite and Samara. First, I'll talk about Samara. Samara is less than 40 pounds. It's a daytime system for aerostats. Because it's less than 40 pounds, it can fly on tactical aerostats, which are very movable and deployable, but it can also be added to a larger aerostat with multiple other sensors, which hasn't been able to be done previously. Samara has been exportable. In fact, we have sold several Samaras to Brazil, and Samara will help safeguard the Summer Olympics this year in Brazil. When we get to Red Kite is our newest sensor. That sensor can be flown on smaller and smaller unmanned aircraft. In fact, in the UAS configuration, Red Kite is only about 20 pounds. If we put it in a pod, and this is our Red Kite sensor right here that's in a pod, this system weighs less than 30 pounds, can also be flown on unmanned aircraft attached under the belly or under a wing, but we've been flying it on manned aircraft as well, to include Cessna aircraft. This has been also built to be exportable and for use in the commercial market. We think the law enforcement community will eventually want to have these, along with, of course, FEMA and other agencies. And then there's a big demand for that on the international market. We also look at red kite because it's so light that it can go into pod type situations with other sensors to make a very lightweight multimodal sensor pod such as the one you see here. What I'd like to do now is I'm going to do a quick imagery demonstration on what we have flown with red kite. We'll let this pull up. So this is a quick look at some imagery that we took down in Destin, Florida. Bill Parker likes this bookmark because it's the Bass Pro Shops in Destin, Florida. We can pinch in or squeeze in, take a look at the moving vehicles. We can pan around, zoom back and forth. If we really want to know where we're looking at, we can pull up a picture of Google Maps and see our overlay on Google Maps. So now you know what you're looking at live, and you're recording that, and you're tracking every mover in the scene with this. And again, you can send this data off of the platform in the air straight down to a tablet such as this or an Android-based smartphone. So very powerful stuff. And again, you can squeeze over here. Other folks might recognize that as the sand traps down in Destin, Florida, if you like to play golf down there. I'll set that down, go back to the presentation. Two other areas outside of wide area motion imagery I want to highlight that Logos is involved in. One is called Serenity. Serenity is a hostile fire detection system which uses both optical and acoustic sensors to get after large weapon systems and explosives. The two together have driven the false alarm rates down to practically nothing, and we can pinpoint the origin of those weapon systems up to 10 kilometers away, 360 degrees. Serenity has been deployed to Iraq as part of an operational needs statement. Our booth is about 3 booths down. Please come down and look at our hybrid motorcycle. This is a DARPA effort where we are making an all-terrain silent mode motorcycle that we call Silent Hawk. It runs on multi-fuel. You can put JP8 in it, Jet A1, you can put diesel in it. You can run on that, and then when you want to go quiet, you shut that engine off and go all electric on the electric battery. And it is 55 decibels at 7 meters. So that's about the sound of a casual conversation in a room or your refrigerator running in the same room that you are. So please stop by our booth and check out Silent Hawk. I think I've got some time for questions if there's any questions.